Hello, my name is Jude. This is my demo 0, where I'll be demonstrating how a basic microprocessor performs a subtraction of 8 minus 3, which is going to result in 5. To start with this, over here on the top, this is our processor, and down here ours is our memory, and we have the data bus right here, which moves everything around. We're gonna start with putting at ROM 0 as our initial value, and for our second value, we're gonna put 3 in ROM 1. After doing that, we're gonna set the write to 0 and the clock to 0 and let our system read. So we're gonna set read to 1. Once we have 1 on read, our this basically just initializes the microprocessor. As you can see, 8 is going from here, 8 is going to there, 8 is going to there, and all the way down here to our data bus. This is looking pretty good right now. um After this step, we can now select 1, our value number 3, and after we select 3, it's going to go all the way up here. Now we can basically enable our store B and run a clock, and that basically stores this into our store B and makes it output 3, which is what we want to do. Once we do that, we can disable it, and we can now change the address to 0, which is our 8 value. So now our data bus has 8. 8 is going to go here. We want it to go up here though, so 8 can go straight to the A value over there in the ALU. So we're going to flip A or B, and now our 8 value is going up there. And as you can see, our result right here is 5. So 8 went in the ALU, and then 3 went in the ALU, and it subtracted A minus B, and it resulted into 5. And since we have that now, we can set our enable our accumulator so that our accumulator can output number 5 into it and store 5 data bits into it. So now we run a clock pulse, and as you can see, 5 is stored into the accumulator now. Once we have 5 stored into the accumulator, we're gonna have to set once we have 5 into the accumulator, we can set the accumulator and disable it basically, and then disable the B, and even how many clock pulses we run, we always that value is still staying there as 5, which is good. That's what we want. And now we can set our output to 1, so we can move this 5 into our storage down here into our memory. But as you can see, we have an error since we're in read mode right now. So in order to move it down there, we're gonna have to write it down there. So we're gonna have to press 1 on write. So now 5 is going from down here into the data bus all the way down here, but we want to send that 1 to RAM 6. In order to send it to RAM 6, we're gonna have to address the write to 6. So we have to, in binary, we're gonna have to put this into 110, which is 6, And then now, if we run a clock pulse, this 5 should go down here and give us a result of 5. And as you can see, we got a result of 5 down there. And that's it. That's how we use a microprocessor. Yeah, so there's registers in here. Registers are just small, fast storage that hold like temporary data during processing. And then if we speak in as if digital and analog, this is a digital system because it uses data in binary, like as in zeros and ones. And as in a bit, I mentioned bit in here. A bit is just the smallest unit of the data, and each register holds 8 bits usually. Types and there's multiple types of registers. There's the microprocessor, and in the microprocessor, and they include like serial and parallel registers that store and route data all around here. So yeah, that's it, and I'll see you in the next demo.